So recording is started. That day we discussed about the theory of the failover. In this failover, we saw what exactly happens, why the unit has to be identical, why the RAM size, why the flash size, why the interfaces, why the model, why the iOS, everything has to be same, and how it works basically. Okay, so I told you that you need to have a LBF. Today, in today's scenario, we do LBF, that is LAN-based failover, where you don't have to stick to a specific interface for failover. You can make any interface as a failover interface. It is recommended that you should have two interfaces, one for stateful, one for failover. So if you see the diagram, let me explain you the diagram. There is one ASA1, and there is one ASA2. I am going to make ASA1 as the primary and ASA2 as the secondary. You can see there are, just because there were more units and more boxes, so I just took only one LAN user and one server instead of two LAN user and two servers in our earlier scenarios. You can see there is a communication, both the PC, that is both the one LAN user as well as the server can access both the ASA. That means both the ASA can be accessed, uh, the LAN PC and the server to the switch. R1 and R2 as normal and R7 as 172, just to show you how the traffic comes in, how the traffic moves on from primary ASA and go to R3 and server. That is R3 belongs to the LAN user. It's a LAN user or LAN PC, which is having a subnet of 192.168.10.0/24. Server belongs to the subnet of 10.1.1.0, and server is having an IP address of 10.1.1.10. You can see I did a redundancy. Okay, there are two switches. Okay, ASA1 is also connected to the same switch, ASA2 is also connected to the same switch, ASA1 is connected to R10 switch, and ASA2 is also connected to the same switch. uh, the full mesh network kind of thing, or this is now partial mesh because there is no communication between R9 and you can do the communication between R9 and R10 also. So ASA1 is also connected with both the devices, ASA2 is also connected with both the devices. At the same time, they are also connected on the outside with the same switch, common switch. They might get connected with multiple switch, and finally you'll be having redundancy through ether channel and all those stuff. So I hope the picture is clear in front of you, that how the communication is. I told you every physical interface that you have to bring it up on ASA router, you should always give IP address. So I also gave an IP address to this failover interface. The failover interface is 10.2.2.1, any private IP address, and the second failover IP address of the secondary firewall is 10.2.2.2 from the same subnet. And same way for stateful interface also, I took 10.3.3.1 and 10.3.3.2. Let's see. This is a new topology, so we lost the configuration of R1. Simple. Interface S1 by 0. IP address 12.1.1.255.255.255.0. Say no shut. Interface E0 by 0. IP address 20.1.1.5. 255.255.255.0. Say no shut. IP route route facing internet to the next hop router, that is 12.1.1.2, 192.168.10.0 10.254.254.254.0. Next hop is 2111. 10.1.1.0. See now, there is always a confusion that what will be the route on R1. Please try to understand. Every time the traffic is forwarded to the primary firewall, or you can say active firewall. And who is the active firewall now? SA1. Whoever becomes active will carry this IP address. So if I'm giving a route for 192 series and 10 series, my next hop always will be 2111. I won't give 2112 because this is the IP address of the standby. Standby is not going to forward any traffic. We are doing active standby failover. Please try to understand. We are doing active standby failover. In active standby, only one firewall is going to work. Another firewall is going to act as a standby unit. Standby unit IP address will never be considered. Oh, good. Today a lot of people join. Okay. Standby unit will never considered for routing. So if active router is ASA1, the traffic is going to be forwarded to 2111. If active router is ASA2, then also the traffic is going to be forwarded to 2111 because now this IP is here. Actually, IP never get fluctuate interface by interface. IP is already there in the form of primary and standby. So whenever I am doing configuration, I am telling my firewall, boss, primary IP is this, secondary IP is this, active firewall IP address is this, standby firewall IP address is this. So whoever become active, suppose this is active, then the IP address is here. If this is active, then the IP address is here. If this is standby, then the IP address is 1.2. If this is standby, then the IP address is 20.1.1.2. So there is no confusion. Router is going to forward all the traffic to 20.1.1. That's all. So one is default route. Okay. Now go to R2. E0 by 0 and say IP address. I'm pointing a default route. So can I go to 12.1.1? Can I go to 20.1.1.5? Yes. Good. show IP int brief ping 192.168.10.1. Now firewall is not ready, so not able to ping. R5 is server. P0/0. So server is ready. Interface E0/0. IP address 172.16.10.2, 255.255.255.0. No shut. IP default gateway 172.16.10.1. No IP routing because we are using this as a host. We can see he is able to. So let me share the diagram. So you got the diagram. Okay. Now ASA1. We are not going to configure ASA2. So last time I think I configured ASA1 with the IP address of 2111 and 2112. Primary is 2111, secondary is 2112, 192.168.10.1, 192.168.10.2, 10.1.1 and 10.1.1.2. So I made a provision for all the interface for standby unit. Okay. Security level has to be 50. So when I say show run, you see I made a provision for outside to the standby unit with the next immediate IP 1 and 2, inside 10.1 and 10.2, 10.1.1 and 10.1.2, security level 0, 100 and 50. So route, now I made, now I have to give a static route. So I said route outside 00 20.1.5. This is the IP address of my router.
Um, is route outside the same command as IP route?
Yes, it is the
Okay.
same command like when you give it on router, you give it IP route, and if you're doing default route, if you're doing static route, then if you're doing default route, you say route. You have to specify the direction of the routing because see, always remember ASA is can have router behind also, in front of him also can be a router. Like in front of him, you can have a router connecting ISP. Okay, you can have a router connecting partners network through lease line or MPLS. So route can be done like that also, routing can be done like that also. Here you might put default route facing internet. Here you might put some static route, or you might be running dynamic routing protocol between partners network. So routing can be done in any direction on ESA. So in ESA you have to mention the direction and the interface name also. This is not there in router. In router you just say IP route and then you give the next hop IP address and the or the interface. That's all. But here you have to give the direction. You have to tell him that you are doing routing in outside direction or inside direction or DMZ direction. So when I say route outside, I am telling him that I want to do routing in the outside direction. I don't have to add 8 zeros. Instead of that, I can put 2 zeros for default route and the next hop router. So when I do this and say show route, you can see the gateway of the last resort is set, and this is a star sign, which is nothing but candidate default route with a AD of 1. Static default route also carries an AD of 1. Now the thing is like this is a switch in between. So let's see what is the problem with this switch, because he is not able to send the traffic to R1. So if I ping this, there also I'm not getting the ping. So see, if you see this is showing the router. So anyway, I need to stop this. I need to edit this. and then start this. Show interface status. Okay, it's up. Let's see now. Ping 12.1.1, ping 12, 172.16.10.1, 10.2. All are successfully pinging. ASA 3, 5, R1, R2, R7. Show CDP neighbor, showing show interface status. 0 by 2 is telling connected to 0 by 0 and 0 by 1. E0 by 0 shut, no shut, shut, no shut. Show interface IP brief. So E0 is connected to E0 by 0, E0 is connected to E0. So once again, if I try to ping myself, 5, pinging, see, 12.1.1, 12.1.2, 172.16, 10.1 and 2. Perfect. Now if you see my second firewall, he is like sitting idle, doing nothing. Only thing you have to do is what? Show run. All the interfaces are shut down. That also you don't have to do, except for the failover interface. So if you see, what I did, I just configured the interfaces, okay, and basic routing. Now I need to do failover configuration, and the failover configuration is simple. It's not that big task. In the active standby, how to configure failover, you have to say on ASA1, not an ASA2, you have to say failover unit, LAN unit, failover LAN unit, primary. So you are telling that from now onwards you are primary boss. He said, okay. Now you have to say which interface you are going to use for failover. So according to our diagram, if you see, we are going to make E6 as an interface for failover, as a failover link, E6. But what is the name of that interface? What naming you want to give? So I said I want to name it as FO, failover. Okay, good. Which interface? So I said E6. So he's telling if you are going to use E6 as a failover link, I'm going to remove all the configuration from E6. I don't want any IP address or blah blah. Like for example, by mistake, if I say E2, so he's going to remove the IP address, security level, name, everything he'll remove. He said, no, sorry boss, you can't keep any data configuration on E6 because he is now going to act as a failover link. So I am not going to allow you to keep any configuration. So he's telling I am going to clear it off. Okay, good. But see, when I say show interface IP brief, this interface E6 is still down administratively. That means what is the first step? You have to make it no shut. So when you say show interface IP brief, you see the interface is now up. So what is the first step? you have to go on that interface which you want to make it as this thing, say E6 or G6, whatever. If it is gigabit or whatever, whichever interface you want, I just make it E6. This is E2. This is E1, and this is E0. Save it. So E0, E1, E2, and E6. So first step is what? Go there and first make it no shut. This is your failover configuration. Failover LAN unit primary, failover LAN interface name and interface ID. Now, which IP address you are planning to give it to the failover? 10.2.2.1. That you don't have to go on the interface and give. You have to use command what? Failover interface, the name of the interface, sorry, IP, the name of the interface. See, now it is available now. I gave A4, no? So command is failover interface IP, name of the interface, and then the IP address. So I thought of giving it what? 10.2.2.1. See my diagram. This is just a private IP address, huh? No need to worry. Any private IP address you can take. Your choice. I told you, no, it is a formality. Every interface, every physical interface of a router, of a firewall will come up only and only when you give an IP address and no shut command. It is not in case of port. I'm talking about a switch port. In switch port, you don't have to give IP address and don't have to say no shut because it is a switch port. Switch port works in a layer 2 mode, but interface always works in layer 3 mode. So layer 3 interfaces always needs an IP address. So it is a formality. So when I say show interface IP brief, you can see that IP address is already there with E6. But remember, I never gave it on interface. I just gave it through failover command in global configuration mode. It's a global configuration command which maps this IP address to active and standby. Failover link or FO link is going to act as a failover link between two boxes for monitoring the health of the active firewall by standby. I told you an example of two office boy. I gave both the office boy one mobile phone, one mobile phone, which is going to be bear the number and the cost will be bear by the office. And this number is specially used to communicate between this office boy. Standby office boy is going to call the active office boy. Are you coming to office today? He say yes. Where are you, man? I am at home. I'm just checking it out. I'm just coming out. Okay, good. After again, have you reached the station? Yes. Have you took the bus or train? Yes. Where are you now? At present, I am near office. Okay. Have you opened the office? Yes. Are you healthy? Yes. Every time there is a communication going on by the standby with the active with that same mobile phone. So same way, this is a failover link between the active and standby box, and there is a communication going on between these two, and they are up now with this IP address. Good. Last but not least is what? Command failover. Okay. Next comes ASA2. ASA2 interface E6. First command, no shut. Next command, failover unit, failover LAN unit secondary, failover interface IP FO E6. Sorry, what was the command? failover LAN interface. FO E6 cleared. Failover interface IP FO, same command. 10.2.2.1 255.255.255.0 standby is what? See, I told you, no, this fellow should also know. And then the command is what? Failure. Detected an active mate. No active mate detected. When I gave failover, he was trying to find out, but he was not ready, no? Detected an active mate. Show failover. Show failover. Now in both the failover, if you see, there is a difference. This host is secondary and standby. See ASA2. This host is primary and active. This host is secondary and standby. Interface outside is 20111. Very good. Interface outside is 20112. Interface inside is 192. I am talking about active. This is no, I am standby. So my IP address is this 2112, 1012, and 1010. But I know who is primary and he is active, and his IP address is 2111.192.160. So this guy also agrees ASA2 that there is a unit called active, and his IP address detail is also with him. Failover is not, stateful failover is not configured.
What is waiting? Waiting.
See, I told you last time also, there is a communication link between ASA1 and ASA2. I told you office boy is carrying a mobile phone. But first office boy, who is a primary office boy, and this is a secondary office boy, by mistake he forgot to charge the mobile phone. So how this fellow will give a call to him? Okay, and he will think what, that this fellow is down, and he will become what, primary. So this is not good, no, because it is not, the mobile is not charged. That means if this link goes down, box is healthy. Box is healthy, only the link has gone down. So if the failover link has gone down, that doesn't mean the failover should take place, no. But there is no communication going on between ASA1 and ASA2, Tushar. So there is a confusion. So the failover is made in such a way that office boy do what? He takes his wife's mobile phone and calls the other guy and say, boss, don't worry, I'm coming, don't do failover. I'm coming, man, to office. Now, what about your mobile phone, man? That has gone down. I forgot to charge, or last night it broke. Okay, no problem. So I got the message from somebody else's phone, na? Or he's traveling in train and suddenly something happens to his phone. Somebody robs his phone. So immediately he took someone's phone next door. Come on, can you please give me your mobile phone to give a call? Just one call, please. Emergency. Okay. Say, hello, don't do failover. Don't come to office. I'm coming, man. Only problem is my mobile. That means this link has gone down, Tushar. So what happens? The message can come directly from this link. From this link. From this link. They are acting as a supporting. See, though they are being used for data. Got it? They are not actually used for your hello messages. But in worst case, if this link is not functioning properly after a timeout, what is the timeout? Can you see? There are two timeouts here. Unit pole frequency is 1 second and the hold time is 15 seconds. That means every 1 second there is a hello message being exchanged and the hold time is 15 seconds. But In case if the monitoring interface is not responding, unit interface pole frequency, that means the other interfaces like outside, inside and DMZ can also send hello messages, but the delay timer is 5 seconds. That means if I don't receive in 1 second, I'm going to wait for 15 seconds. Okay, no problem. So I got message on 10 a.m. Now next message should come in 1 second. So I didn't got the message. I'm going to wait for 15 seconds. But you see, in 5 seconds, I'll be getting the message from other interface. Hello. So my whole time is always more, na? 15 seconds. Within 5 seconds, I will get. And my whole time here in the next interface, that is the pole interfaces, the other interface is 25 seconds. That is again more than 15 seconds. So definitely I won't do failover. I will wait. First, I will wait for primary link. If primary link is not responding, then I will wait for the other interfaces which are considered as they are doing meherbani or they are doing favor. Meherbani means favor for others. They are doing favor. Who? Outside, inside and DMZ. They are not designed to send your hello message. But in worst case, like if you are asking somebody's phone and telling, let me inform my wife I'm coming late today. Because wife must be worried, no? You're gone to party there and you forgot to charge your mobile phone. I don't know, purposely you must have done so that your call should not come from wife. And then you after after 2-3 drinks you must have gone you lost. Then finally you remember that you have to call your wife and tell her that you're going to come midnight or in the early morning. Otherwise she will kick you out of the house. So you borrowed somebody's phone and you say, sorry, my phone got battery discharge and blah blah and all those excuses like that. So at least at least you made a safe this thing. Okay, afterwards, after finishing the party. Okay, so let's see. Now see, earlier it was waiting. Waiting means they are being considered as the monitoring interfaces. So by default, yes, they are being considered now as a monitoring interface. The term is monitoring interfaces. Monitoring means actually your failover link is up. Your failover LAN interface is up and working fine. But in case if this goes down, then the monitoring interface will be taken into consideration. Which are the monitoring interface? These are the monitoring interface. Waiting means still he is trying to find out this interface. Got it? It takes time to come up. So let me see. Show interface IP brief. Show run. So your inside interface definitely is going to act as a monitoring interface, but it takes time sometimes. Waiting. But definitely he's going to consider all the three interface acting. See, he detected the version also. See, 9.1 subversion also has to match. Bracket 516. See, he tried to find out. Failover LAN interface is FO. The name of the interface is FO. Any name you can give. Interface Ethernet 6 up. Normal hello time is 1 second and hold is 15 seconds from the primary link. In case if that link is not responding, then my monitoring interface hello time is 5 seconds and hold time is 25 seconds. That means definitely there will be a delay in doing failover. You can reduce the timers also. It's not a big task. He's just testing. Until unless everything is okay, it's not going to make him the monitoring interface. Anyway. But actually the failover link is up. So I hope you understood what is the difference between monitoring interface, what is the difference between failover interface. So monitoring interface, definitely your original mobile will be considered as the best one when you receive a call. Okay. But in case if your mobile is not working, you can call your wife from somebody else's phone. There should be a chance that she should pick up the call. If she's not picking up the call, then there is a problem, because many times unknown calls nobody picks up, no, and you are desperate to call her from the somebody else's phone. You can explain her, okay, I have borrowed the phone from my friend or from the unknown person. You just take it. Okay. Anyway, I hope you understood. See, show route on ASA2, when I say show route, you can see everything has come. Show interface, IP brief, everything is there. ASA2, in fact, even the host name also same. But you can find out with the help of the tag outside on the box. And when you do failover, you can see this host is going to act as a secondary, and secondary's IP address is this, and the primary is IP address. So this ASA2 knows what is his role now. ASA1 also knows what is his role. He knows that he is active and the other guy is standby. Okay. So let's see if I shut down this interface. Okay, no failure. Actually, I'm purposely doing shutdown, no? That is why it's, we have one more way to do that. Where is this interface gone directly? If it is connected through some switch, no, we can bring this down also. Got it? He's not allowing me to shut because this is a failover link, no? If it is connected through some switch, in that case, we can even stop from the switch and see if the failover is working. It should not work basically. Why? Because I told you your link has gone down, your box is still working. So if your link has gone down, you're going to make use of the monitoring interface. That's all. Monitoring interface can be taken into consideration. So what I will do in the next lecture, I will put one box here, switch, and we can remove the cable from that switch, and I will show you how the monitoring interface works. Anyway, now I try to add one access list here. I say access list. See, I'm adding the access list on ASA2. I should add it on ASA1. So I say out underscore in permit TCP anybody to come on host 10.1.1.10 for traffic 23. See, it's telling what? Warning. Configuration replication is not performed from standby unit to active unit. Configurations are no longer synchronized. You could have done this on primary. Why you did it on this? So I'm going to do this here. Access list out underscore in permit ICMP any on host access group. When I say write standby, he's going to send. If I do WR also, he is going to send it. See, beginning configuration replication from mate. Show version. Why the okay. So when I say show access list, you can see show run access group. You can see. So this is my secondary unit. I did it in primary. Show access list. Show run access group. Immediately the information is getting synced. Let's see if telnet works. So I need to enable secret Cisco line VTY04 password Cisco transport input telnet SSH. I say telnet 172.16 10.1.1.10. ping 10.1.1.10, ping, ping 172.16.10.2, pinging. Okay, let's see the routing. Ping 20.1.1.1, pinging 20.1.1.2. See, standby unit will also ping, huh? Because he is also connected to the same switch with the same IP. But who is going to process the traffic? Definitely SA1. Show IP route. Show access list. Yes, there is a hit count also. Cisco. Now you see, when I say show CONN detail, this connection is active on SA1. Can you see? 172.16.10.2 is trying to access 10.1.1.10. Flag is UIOB, that means the connection is still active. But when you go and ASA2 and say show connection detail, nothing is there. When I go here and say show interface E0, you can see there are number of packets being input and output. But when you go on show interface E0, this is like we must have just now tried to ping, no, from R1. So I got these packets. Otherwise, you see 680, 200 and 497. Once again I disconnect and try to send ping also. Repeat 100. Now you see 680, 200 and 497, 794, 312 and 497. Can you see? One more time. 795, 795. 797, 315 packets. What about this interface? 43, 45 and 0 packet drop. There might be some broadcast or something going on. Otherwise, you see the count is not increasing. 53 packets only. That means ASA2 is not processing any traffic. When I say show CONN detail, it is ASA1 which is processing the traffic. It is not the ASA1. ASA2 is still, because ASA1 is active. So when I say show CONN detail, it is ASA1 who is forwarding the traffic. It is not the ASA2. Clear? Now we'll do one thing. We'll see how the failover works. For that, I'll do what? I'll go on the switch. Show CDP neighbor, I won't be able to see. Show interface. Interface E0 by 0. I shut it down. So what I did? I shut E0 by 0, which is connected to ASA1. See, the ping is struggling now. switching to active, switching to standby, ping started. See the drop. Now I say show failover. Active time is 8 seconds. Now he is telling boss, I am active. Though I am a secondary box, I am active. And primary is failed. So when I say show CUN in detail now, I can see the active connection on ASA2. And now you can see there are packets increasing on outside. If I do telnet, you can see shows UNN connection detail. Now ASA2 is managing the show. What happens if ASA1 comes back? What happens if ASA1 comes back? Show failure. Primary is failed. He has failed. He is acquiring the standby IP address, but he's failed now. He's telling my secondary unit is active now. Let's see if he come back. I told you preemption is not there. See, this host is primary and he is standby now. I told you preemption is not there. So I make him failover primary. Sorry, failover active. So when I say failover active, now he becomes active immediately, and this guy becomes standby. Whatever master says, master is telling you become secondary, standby. Forcefully I made him primary because preemption is by default not enabled in active standby. One unit is definitely acting as active and one unit is standby. In case if the primary unit goes down, standby unit becomes active and the primary unit becomes standby when it comes back. It will never switch over to active. If you want, you can forcefully make him active. Got it? I hope this is clear with you guys. Now I wanted to show you the MAC address. I told you, no, R9 is a switch between R3 and ASA. Can you see? R9 is the switch between R3 and ASA. You can see there is a MAC being registered on E0 by 0. Just one minute. Hello. Just give me 1 minute. I'll just send something and then I'm just sending something. Okay. So I was just showing you how the MAC address take place. When I go here, oh, R9 is what? Okay, 1 minute. Huh? Show interface status. Show MAC address table dynamic. Now see there is no activity, so it's not there. So ASA1 will send a ping packet to 192.168.10.10. Oh. Interface E0 by 1 shut, no shut. E0 by 2. Ten dot one dot one dot 10. Sorry. So now I go here and say show MAC address table dynamic. One 192.168.10.1. 10.1.1.1. Now you see I have received MAC address from E0 by 1, that is 3010. MAC address from E0 by 2, that is switch MAC address, and MAC address from E0 by 0. If you see the MAC address from E0 by 0 is 5000.008.0.0.1. Okay. This is a virtual MAC address. And if I go here and say show ARP, you can see the same MAC address is being sent in the ARP reply by ASA for 192.168.10.1. Can you see? This is a virtual MAC address, boss. This MAC address doesn't belong to interface E1. One minute. Huh? Actually, it is a virtual MAC address. It's not showing you the physical MAC address. Okay. Because see, when the failover take place, see, this is the MAC address available with LAN PC. Show ARP. This is the MAC address available with for E2. Show interface E2. Okay. Let's see. Show interface E1. See, virtual MAC address. Otherwise, you cannot have two same MAC address on two interfaces. Five thousand 0.0.8.0.0.1. Same MAC address on? No. This is 5000.008.001, 5000.000C.001. Okay. So show ARP 5000.008.002. Let's check for E2. 5000.008.002. Five thousand zero zero C 002. Okay, so let's see now. This is the MAC address that my LAN PC has stored in his ARP for 192.168.10.1, and this is the MAC address this fellow has stored for ARP of 10.11. Okay, now let's bring this down. ASA1, we bring it down again, E0 by 0. Show failover. He's still not taken the active position. Show ARP is still showing same MAC address. Okay, this fellow has switched to active unit. Show ARP is still showing the same MAC address. Let's see. Show interface E1 00800. I told you, no, this is not the physical MAC address. Physical MAC address cannot fluctuate, cannot go from one end to another end. It is the virtual only. That is why, see, this fellow has stored 5000.008.001. ASA2 was earlier having something else. What was the MAC address? 00C. In between there was 00C for E2. And for E1, again in between it was 00C. But now you see, for interface E1, it is having 008. And for interface E2, also he is having 008. That means this is definitely a virtual MAC address. Our table is still having the same MAC address. 001, in between there is 000 and 8. Clear, all of you? This is nothing but a virtual MAC address getting fluctuated. It's in HSRP and VRRP on router. It is a dedicated virtual MAC address that fluctuates between active and standby. Here we don't have a dedicated virtual MAC address. It is the virtual MAC address given to E1 and E2 when you enable failover. Their actual physical MAC address is not shown on interface. They carry now virtual MAC address, and their virtual MAC address is getting fluctuated. Again, if I bring this back, still failed. Ready? Still the MAC address is same, 008.001. Still the MAC address is same, 008.002. Because I told you, no, this is not active firewall. So I said no. failover active, you become active. So now you see show interface E1, show interface E1. Now this fellow got 008001, and this fellow got 008002, and this fellow again went back to his own MAC address 00C001 and 00C002. Clear with the virtual MAC address, all of you? If we can make this, okay, let's check with the monitoring interface. So what we'll do, WR, WR, we'll stop this, delete this, add a node, I add a node, switch, so at present we'll add only one interface, E6, or let's add E7 also. E6, E7. Just keep aside. So E6 and E7 I added. Here also E6, E7, E7. Start. Let's see how the monitoring interface works. Let it come back. SA1 show failover active, show failover standby. Still monitoring interface is not up. Monitor interface inside. You can also forcefully make them monitoring interface. So when I say show failover, if it is not taking automatically, you can force them to become a monitoring interface. Show failure, monitor. Let's see now. ASA1 is active now and primary. ASA2 is standby. ASA1 is healthy. How you know that he is healthy? One minute. You're trying to send telnet. So IP INT. So this guy is telnet. Show connection detail. Working fine. Now for some reason, this is the new switch. E6. E0 by 0 goes into shutdown mode. E0 by 0 shuts down. I hope you understood what I did. I shut down this E0 by 0, the monitoring interface between ASA1 and ASA2. Show failure. He's still standby and ready when he can. Okay. Telnet session is working. When I say no switchover, failover LAN failed, but there is no switchover. See, he is himself telling failover LAN failed, but there is no switchover. Why? Because when I say show failover interface E1, failover interface system IP address 10.2.2.1, IP address is 10. Okay. Show monitor interface E1. Who are the monitoring interface? These are the monitoring. Still the telnet is active. See, failover LAN has failed, but just because they were monitored, we'll do one thing. We'll bring it back. See, failed, no switchover. Once again, we'll shut down once again. Wanted to show you that, forgot. Shut. Show failure. E6 failed. 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 Let's bring it back. Wait for some time. Let's see if this comes back. Failover LAN become okay. Up, up. Clear? Just because these were the monitoring interfaces, failover didn't took place. Why? Because I told you, unit fold frequency is 1 second and hold time is 15 seconds. So within 15 seconds, you must have received the hello from monitoring interface. Clear, all of you? Now same active standby can be done with stateful also. In active standby, failover can be done with stateful also. So I have to add one more link. Already I added E7. So I need to say E7 suppose. Instead of here E6, here I said E7. It can be same interface as FO or different available interface. So I said on ASA1 failover link. I gave state full. This is just the name of that physical interface. Which physical interface? E7. We can give anything. But remember, don't forget to say no shut. Step 1 is what? Config T, interface E7, no shut. Don't forget this. So stateful can be done in active standby also. You have to give a command. Failover LAN unit primary is gone now. You have to say failover link, name of the interface. You gave stateful, you can give any name. E7, you specified the interface. And then you said failover interface IP. Then you will get the name which you kept. Stateful 10.3.3.1, 10.3, 10.3.3.2. I hope you remember in my diagram I gave 10.3.3.1 and 10.3.3.2. So I'm using the same IP address. I told you failover HTTP traffic is not by default failover. So you need to say failover replication HTTP. So when I say write standby, and when I go here and say show failover, see stateful failover unconfigured. Now when I go here and say state show failover, you can see stateful failover link is configured with the name stateful, and up all these TCP connections, UDP connection, everything will be taken care now. You can see there is no transmit and receive. So we'll do one thing. Show failover. Pay attention, all of you. This is also up now. You don't have to do anything on ASA2. Huh? This you have to do only on primary ASA. Stateful failover commands to be done only on primary ASA, and then do write standby. Got it? You don't have to do it on secondary. Save. Now I go here and say show failover. Pay attention. ASA1 is active. ASA2 is standby. Now this fellow sends a telnet traffic. Can you see the statistics here? For TCP connection is 0. Receive is 0. Telnet Cisco enable Cisco. Now you go here on ASA and say show failover. Can you see the statistics is 8? Earlier it was 6. Now it is what? 8. Some activity is going on. Show CONN detail. Can you see? ASA1 is taking care of this connection. Show IP INT brief server. Working fine. ASA1 is taking care of this connection. But ASA2 also at the same time taking care of this connection. Can you see? Both of them is having this connection. So failover. Can you see? He received it. From where he received? He received it from the primary firewall. He has not transmitted anything. Huh? He received this connection detail from the, so that is why you see this is active. Connection is still active. Okay. Now what you will do? You will do that same process. You will go here, config T, which switch? Switch, this switch. And we down this E0 by 0. Shut. Okay. So failover is still active. Let's see. This fellow still active with this connection. Still active with this connection. Switching to standby. Still active with this connection. What? Normally it shows CON in details. Still the connection is active. Still this fellow is telnet in this server. Who? Can you see the connection is active? So, oh, right. I never did once again telnet. I never did once again telnet. It was the same connection. She is telling me from last this fellow is connected. This fellow is gone. Showing this older connection. This is the actual connection. Active connection. Uptime is 1 minute 49 seconds. 54 seconds. See, he's synchronizing it with box, lost the connection with the outside. No, sir. Connection is still active. Connection is still active. Show failover. Show CON in detail. Connections already active with ASA2. This is active, this is failed. See, this has become now standby. So let's bring this fellow also down, ASA2 also down, E0 by 1, E0 by 1, E0 by 1, shut down. Show failover. Show CON in detail. Connection is still up. Show CON in detail. Show failover. Show connection detail. Show failover. R5. ASA switch to active. Connection detail. Show failover. He received the connection from ASA2 when he was down. He's now active. See here, I didn't do any telnet once again. They're from long back. Telnet. Ooh, active. So I hope you guys understood how to configure active standby failover between two units. I showed you all the basic things also, like how the ARC table is built, how the virtual MAC address switch over from interface. I showed you how the monitoring interface works. If you shut down the failover link, doesn't mean failover take place. There is no communication between this failover link, but still there is other monitoring interface to hand over this hello messages. Extra job. It's your choice. Huh? If you don't want, you can disable also. If you want to play safe, you can do it. I hope you guys understood today's lecture. I'll be sending you the recording and the configuration file for failover. Next lecture, that is tomorrow, we are going to do active failover. Okay. Good night. Have a nice day. Bye. Take care. Thank you, all of you, for listening.